In previous video, we discussed about the chi-square test as a goodness of fit test. Now we are going to discuss about the when we have a data in tabular form. Like here we have two attributes. That is what attacked by smallpox or non-attacked, and the respondent are vaccinated or non-vaccinated. So in this case, we have total 2000 respondent. Out of 2000 respondent, 31 were vaccinated and attacked by smallpox, and 469 were vaccinated and non-attacked. Similarly, 185 were attacked by smallpox and they were non-vaccinated. Similarly, 1315 were non-attacked and they were not vaccinated. If we see, the total 500 respondents were vaccinated and 1500 were non-vaccinated. 216 were attacked by smallpox and 1784 were not attacked. So I want to check that vaccination is effective or not to preventing smallpox. So as per our null hypothesis, that there is no effect of vaccination to prevent smallpox. It is our null hypothesis. Now this is this is what observed data, and we have to calculate the expected. How we will calculate expected? What we will do, we will divide the total 2000 respondent on the basis of ratio. But I'm going to tell you a direct, very simple method to calculate the expected, and how we will calculate it. It is very simple. If I am going to calculate the expected data for this, that is what vaccinated and attacked, what we will do, we will take total of column, that is 216. Then we will multiply by total of row, that is 500. Because of, if I'm talking about 31, so total of column is what? 216, and total is row of what? 500. So 216 into 500 divided by the grand total, and grand total is what? We have grand total is 2000, so divided by 2000. Similarly, if we talk about this non-attacked, the total of column is 1784, multiplied by total of row is 500 divided by 2000. And similarly for this 185, total of row is 216, and total of column is 216, total of row is 1500 divided by 2000. And for this 1784 multiplied by 1500 divided by 2000. So what we are going to do, we are going to find the calculate the expected. As you can see, we calculated like this. The value of that calculation is what? 54, 446, 262 and 1338. It is what the expected. And to find the chi-square value, so it is our observed data on the basis of this table. That is what? 31, 185, 469, 1315. So this is what? 31, 158, 469 and 1350. And this is our expected value. So expected value is 54, then 446, 162 and 138. This is what observed and this is expected. Now we will calculate observed minus expected, then observed minus expected whole square, then observed minus expected whole square divided by expected. So we will calculate the value of each. Observed minus expected whole square divided by expected. Then we will do total of it. When we will do total of this column, it becomes 14.642. This is what the value of chi-square. And this is calculated value of chi-square. Now we are going to compare it with critical value. And how we'll find the critical value? For degree of freedom, because of it is a case of attribute, we have values in row wise and column wise. So how many attributes in like sample into the row? That is 2. In column 2. So degree of freedom is what? Row minus 1 into column minus 1. So 2 minus 1 multiply by column minus 1, that is 2 minus 1. So 2 minus 1 is 1, into 2 minus 1 is 1, 1 into 1 is 1. This is what degree of freedom. And if we will check from the table, if we will find the table value of chi-square at 5% level of significance and 1% degree of 1 degree of freedom and 5% level of significance, that critical value is what? 3.845. And I told you that if your calculated value of chi-square is less than critical value of chi-square, that is what? Critical value, or we can say table value, you will accept null hypothesis. But in this case, our calculated value is more than what? Calculated critical value. Our calculated value is more than critical value. So what we will do? We will reject our null hypothesis. And what our null hypothesis? That there is no significant effect of vaccination on the smallpox, but our calculated value is higher than the critical value, so that we will reject our null hypothesis and we will accept the alternative hypothesis that says what? That vaccination is effective in preventing attack from smallpox. So this is all about when we have two attributes and how we will find the test of goodness of fit through chi-square test. The same process we will use.